Okay, so the proof here is going to be pretty similar to the last question, at least I think so. We'll start off by assuming there are a finite number of primes of that form, and we'll let q equal 4 times the product of those primes minus 1. So q would be equal to, or congruent to, minus 1 mod 4, which is the same thing as 3 mod 4. Okay. Now, let's prime factorize q. Oh, and of course, none of these p's can be dividing q. So q will be a product of primes. Let's just call them p1, p2, up to p, let's say l star. And none of these primes are in the list of original primes because 1, 2. Since none of them can divide q because of how we constructed q. So let's have a look here at the q. So there's a couple of situations we can have here. This, so we'll just take pi star. So pi star could be congruent with 0 mod 4, 3 mod 4. Okay, so this one here is a problem because it would basically mean that we found a prime that is not, we know that this is not in the list. This p here can't be one of these, but if it is equal to 0 mod 4, then it would have to be a multiple of 4. So it couldn't possibly be prime, so this is not possible. If it was equal to 1, I think that's possible. If it's equal to 2, then that would mean it's even, so that would be a no. If it's equal to 3, is that okay? Actually, could it be equal to 3 mod 4? That might be okay. Yeah, that's okay. So that's a yes. So if you were to look at the product here, they can't all be 1, because 1 times 1 times 1, if we were just to look at this, etc., etc., that would equal 1 mod 4. So that's a problem because it needs to equal 3, which is not equal to 3, so we can't have that. If we had 3 here and 1, that would be equal to 3 mod 4. So yeah, that would be good. And then likewise here, if you had 3 times 3, etc. 9, that would be back to 1 mod 4. So that would be a no. It's not equal to the 3 that we need. So we conclude that in these products of primes, there's at least one, or maybe more precisely an odd number do I have this right? Do I have this right? Yeah, in this one here, at least one prime is 3 mod 4, or in other words, minus 1 mod 4, or in other words, i.e. There's a new prime of the form 4n minus 1. So that's the contradiction, I think. I think that's okay. I'm not 100% confident about this one. It's similar to the last one anyways.